Welcome everyone to this webcast on tackling sustainability regulations with data and AI. So my name is Sophie Sanders and I'm joined by my colleague Melissa, and we are both data and AI consultants for Thorogood, based in our London and Boston offices. So today we'll start off with a bit about Thorogood. So then Melissa will present an overview of sustainability regulations, which we're seeing our clients prepare for. And then we'll do some demonstrations of how technologies can be leveraged to address regulations within your data strategy, focusing specifically on plastic tax and EUDR regulations. And then finally, we'll close today's session with next steps. So who are we? What do we do? Thorogood are a professional services consulting firm specializing in data and AI solutions. We operate as a single organization, working in leveraged teams across offices worldwide, and we provide a range of services to our clients to support them reaching their business goals. This includes end-to-end lifecycle delivery of projects, defining initial roadmaps by gathering requirements, designing and implementing complex systems, and also training and supporting business users with tools. So Thorogood applies this expertise to deliver solutions for clients in terms of technologies we work with. So we are an independent consulting firm, which means we don't work with one specific technology. We partner with a range of leading technology vendors in the data and AI space in order to provide our clients with solutions that best suit their needs. And our independence allows us to provide an unbiased perspective to all of our customers, which is particularly valuable working on sustainability, which is a dynamically changing landscape with changing data requirements. So I'll now hand over to my colleague Melissa, who will provide an overview of sustainability regulations.
All right. Thank you, Sophie. So we are going to go through some of the upcoming regulations that we see coming through governmental agencies and other alliances internationally here. So sustainability and eco-conscious efforts have become at the forefront of our minds, both as a consumer and within our industries and businesses we work in. We are seeing world leaders and international organizations call for the immediate actions of individuals, companies, and governments to lessen their impact on the environment. In some of our prior webcasts, we have aimed to educate in the rising importance of defining quantifiable sustainability goals and considerations when building data platform for sustainability metrics, all of which can be accessed on our webpage in case you're interested. However, in this webcast, we want to delve deeper into regulations being established globally, what this means for our customers, and how we can respond to these regulations with modern technology in a mindful manner. Regulations have begun rolling out throughout the globe and have been brought in at an ever-increasing rate for companies to deal with and having to ensure their compliance. Displayed on the screen is a timeline of sustainability incoming regulations over the next 3 years. In 2024, we're seeing updates to the EUDR through the EU, which includes the EU Green Claims Directive, revision of the EU legislation on packaging and packaging waste, as well as the EU Eco-Design for Sustainability products. Then in 2025, we're seeing companies that must be prepared to respond to the CSRD regulations, which entitles companies to report on their sustainability metrics. We're also seeing bodies of alliances rolling out different regulations as well. Finally, in 2026, we're seeing regulations being imposed by the SEC in the US and demanding disclosures of climate risk assessments and transition plans for non-renewable energy forms. By the timeline, we know the imperative regulations for the next 3 years, but there are many more being introduced when we look even farther forward. It's imperative for companies to act now when adapting their analytics and data strategy to forward-thinking, flexible, and modern technologies that can be applied throughout their organization. As we have worked with our customers on their sustainability roadmaps and implementation, it has become apparent that data and technology will serve as a key enabler in helping organizations become responsive to these regulations. As an example, the roadmaps we are defining with our customers is looking to first establish a robust foundation of trusted data that the entire organization can leverage. This set of data has enabled us to build applications for our customers that caters to their primary sustainability reporting and analysis needs. This includes scope 1 through 3 analysis, as well as plastic usage, which you'll see in a use case later today. Once this platform is set up and it shows my impact for today, companies are pushing to understand what they can do to drive improvements, to reduce their impact, meet their targets, and conform to incoming regulations. To do this, we need data, and not just data in that robust platform, but more detailed and novel sources of data combined with new modern techniques. One customer of ours is looking to understand the impact its manufacturing operations have on the natural environment around the sites, as well as upstream and downstream in the supply chain. Or, for example, we'll see it in a demo later today, the understanding of paper-based goods and their contribution to deforestation, and therefore the impact of EUDR, which Sophie will cover later in this webinar. For this type of scenario, where organizations are looking to understand their impact on nature, we need new sources of data combined with new technologies to get a holistic view of the impact on our environment at a scale which was previously not possible. And in setting up the ability to do this kind of analysis in conjunction with that robust foundation of trusted data that we previously built, we can set up a platform that is agile in responding to any future needs, whether it be sustainability or not, as well as newer and complex regulations coming through and demands for data, as well as rapid analysis from both within organizations, but also from governments, investors, and other bodies such as global alliances. Now we're going to hop into the demo of plastic tax. We're going to look at the use case of the plastic tax regulation and see how we can implement modern technologies to allow for efficient and effective tracing of plastic throughout the supply chain. As we've just seen that large amount of regulation, we're going to dive deeper into the plastic tax. The plastic tax has been introduced throughout the EU, with each country getting the opportunity to define their own regulations. For example, the way the HMRC in the UK defines it is a tax on plastic that is not only which the plastic is sold into the UK market, but also what is used in the manufacturing of it. And while this broad definition is shared by other countries in the EU, there are several aspects in which the implementation of the law is a little different in different countries. As for when, this tax has already begun to take effect, with the UK starting as early as 2022 and other countries implementing along the way. Companies must continue to comply with these regulations in order to minimize any reputational risks and also to continue selling or manufacturing their goods within the UK and the EU. Now, let's get a little bit deeper into the how do we meet the end state of this regulation? As we talked about on the previous slide, the far-reaching effects of the plastic tax span throughout the supply chain and will require both external and internal data sources in order to calculate. This means that data becomes the crucial asset when looking to comprehend the entirety of your supply chain. The data will be needed to understand the source of the plastic, who the supplier is, where the end product is being sold, and many additional questions along the way will become essential when a global organization must respond to regulations such as the plastic tax. This means we will need data surrounding the sourcing, supply, manufacturing, distribution, and retail or sale of all products. With this increasing need to trace across the supply chain, we must think about the best technology for this use case. In the past, our preference would have been to store the data in a relational database. However, there are some drawbacks to this approach, which we'll explore in the next slide. Here you can see an example of what a tabular system might look like. You can see that we have a data set for suppliers, plants, distribution centers, and a bill of materials. These relationships in a tabular manner can become very complicated very quickly, as several plants and distribution centers, which in turn sell thousands of products to hundreds of countries. With increasing interconnectedness between data sets, gaining analytical insights can become challenging when using traditional tabular systems. Now, bringing it back to the plastic tax case, we need to understand two complex relationships. The first, understanding all the various forms of plastic that are going in our products and where they're sourced from. And the second, getting a full picture of the supply chain, answering questions surrounding the process needed to create the product, what materials are used, and where the product is sold. Only when we combine these two relationships can we get a good picture of not only all the plastic sold into the market, but also all the plastic that is utilized in the manufacturing process and the logistics. To do this at scale, we must look beyond the typical tabular structure and turn to graph database technologies. So before we get into the actual demo, let's learn a little bit more about graph databases. Graph databases revolve around two structures, nodes and edges. Nodes, in the case on the right, would be the vertices of plant, supplier, and distribution, where edges would represent the relationships between these vertices. By storing the data in this manner, it allows developers to emphasize and efficiently analyze the relationship between data points. Compared to the tabular model on the previous slide, Graph databases are set up to understand and analyze relationships without the need for complex queries. The storing of these relationships will then allow us to quickly traverse through the graph to trace back through the supply chain. So at this point, I'm going to jump over to a quick summary of what we're going to do in the demo. So as chatted about, we're going to use multiple different data sources throughout the supply chain. This will include both internal data, such as shipments, supply chain metrics, and POS data, while also combining it with external views, such as sales, and then also some other sustainability metrics. Once we've identified the necessary data sources, we will use graph databases to explore the relationships between the data sets and analyze our results. Finally, we can use some of the capabilities within the graph database to understand the relationships throughout the supply chain. Now, let me pull up our sample graph database. All right, so on the screen here, you can see a sample graph database that we have built out for this demo. You can see all the interconnectedness between the nodes and different relationships that each node has to each other. This just goes to show how complex these relationships can be, especially for a node such as a material that is being sourced from a supplier and is being used to create products, where it's being stored, how much it costs, are all things that sit within this database. You can see on the top here that we have 2 products, all being created from 5 different materials. These circles here notify us that they are vertices. We can store primary IDs on these nodes, and then each node will be connected by a different edge. Hopefully this gives a little bit of an understanding of how we can trace back through the supply chain. For example, if I were to hover over the material, you can see how connected that material is. You can see that it is supplied from supplier 2 and that there are plastic packaging on that material. And you can see that it goes to create product F within the end of the supply chain. One great capability of graph databases is the ability to query. So what you are able to do is write queries that allow us to traverse through this graph. And this particular query, it's a little simple here, but it allows us to select a set of vertexes and then understand how they are connected. So going back here, we would be able to select this material and understand how it is connected to product F, or be able to trace back to the country that it was created in. At this point, I'm going to hand it over to Sophie, who is going to talk a little bit about the EUDR Act and also build upon how we can build upon this flexible data platform within our systems.
Thank you, Melissa. So yes, as I'm now going to change focus to another regulation, which is EUDR. So first, it's important to understand the key components of this regulation. So EUDR, which stands for the European Deforestation Regulation, started in 2023, however has a deadline for compliance at the end of this year on the 30th of December 2024. Who does this affect? So it will impact on all operators and traders on the EU market and organisations which export certain EU commodities. The specific commodities being tracked under this regulation include palm oil, soy, cocoa and wood, as well as other derived products, for example, chocolate or leather, which is produced from these commodities. So now what is required for reporting? So organisations using these products in their goods which enter the EU need to prove that they weren't grown on deforested land. So producing due diligence statements for these goods at the shipment level is needed. And why is it important for organisations to adhere to this regulation? Well, risks of non-compliance are really significant, including fines of up to 4% of EU turnover, which for some of our clients would fall in the hundreds of millions of pounds. And other risks include banning of products and restriction of market access. And this is in addition to the reputational damage which non-compliance could cause your company. So it's really of top priority for organisations to understand how to report for this regulation, and leveraging data will be a key part of fulfilling this reporting. Also, I want to highlight that investigating deforestation is unique because it requires spatial analysis. So for such analysis, internal data assets from supply chain, sustainability and biosources needs to be combined to trace commodities throughout your supply chain. But to measure deforestation, organisations will not usually measure deforestation or tree cover density themselves. Instead, this requires integration of external geospatial data sets into your platforms. So for example, looking on the right side of this slide, you can see under external, there is a screenshot of a tree cover density map from South America. This is an example of external data set you might want to source. And there are many trusted publicly available geospatial data sets which you might want to leverage to do such analysis. So some options are shown on the right side of the screen as well. So the key idea from this slide is to design your data architecture to integrate this external geolocated data with your internal data to produce analysis. So now let's go through a specific use case to demonstrate how to respond to EUDR. So for this scenario on the screen, a large consumer goods organisation is aiming to trace palm oil in their supply chain. So palm oil is a commodity that is under the scope of EUDR that I explained earlier. And there are certain certifications that before EUDR, suppliers of products from forests might have applied for certifications like the voluntary FSC certification to show that their sources and suppliers meet responsible forestry standards. But for the new EUDR regulation, this requires a higher granularity of automated information and is mandatory. So for this example on the slide, an organisation aims to produce an EUDR due diligence statement for a specific shipment entering France. So they're aiming to investigate the risk of deforestation at their farms where they source palm oil used for this shipment. So linking back to Melissa's demonstration earlier, for this use case, we want to trace palm oil throughout a network. So this tracing aim is really suited to utilising graph databases, as from the graph analysis, we can trace the shipment to the farms where palm oil is sourced from. And in the supplier data, we can also get these geo-coordinates which define the farm location. So now that we get this information from the internal data from graph analysis about the farm's location, we want to combine this with external geospatial data and to understand if there's deforestation at the site, which is what a demo I'll show you now is going to do. And you can see on the screen a plot of where a farm's location was in red, and then the external data of the map in the background. Before I launch into the demo, I just want to do an overview of the flow for this use case. So first, we source internal and external data, assuming that the farm's geo-coordinates of its perimeter have been sourced from graph analysis. These coordinates form a polygon plot, and we want to overlay that over a map of tree cover density to understand deforestation at the site, which I'll do during the demo. And this is with the aim of producing due diligence statements eventually. So to do this, I will now navigate to Databricks. So Databricks is a technology which Thorogood partners with. So displayed on the notebook on the screen is a notebook I've developed which investigates tree cover density change in farms where palm oil is sourced from in this France shipment. So to go through the steps of this notebook, we start off by reading in the file which has the geo-coordinates that I've traced palm oil to during graph analysis. So each one of these rows that represents a different farm. And for this demo, I'll just focus on one of these rows. So we're going to look at a row that links to Para, Brazil, which is a region known for palm oil sourcing, because that's why it's a good example to show in this demo. And then now looking at the visualization. So I start off by reading in our files in a GeoTIFF format. And for those of you who aren't familiar with geospatial data, this is a raster geospatial data set, which means it uses pixels. And I've also sourced geospatial tree cover density file for 2024 for this region, and also 2020. And we've used 2020 and 2024 specifically because we need to do EUDR reporting comparing now to 2020 baseline. I don't want to transform this data to look at the change over this period. So when looking at the difference, red represents a decrease in tree cover density and green represents an increase. But we only want to look at our farm and how the tree cover density has changed within that. So to do this, we want to combine the coordinates with this map. So first I use the coordinates and check it's in the same coordinate system. So this is important as if I'm layering internal and external data, it won't be compatible if we're using different coordinate systems and it will cause an error. So now that we've transformed the coordinates into the same system, showing the plot, and we've cropped the plot just to our farm. And in this example, we had a polygon farm plot that was a rectangle, which you can see. And we can also do this for 2024 data. And again, calculating the difference, you can see here that the overall in the map, there's a positive change. There's also numerical calculations you can do based on this as well. So you can see here, highlighted is average tree cover change. So it's taking the average tree cover density changing across this geospatial cropped file. But we don't want to just do this analysis for one farm. We want to look at all of the farms that we're sourcing palm oil for the shipment. So automating this process, you can get the average tree cover change for each of the farms. And this is really useful because if there's a farm with a large negative change, then you know that you probably want to shift from using this as a source and maybe look at a farm with a positive change, so that making sure that you're not sourcing products from farms that are at risk of deforestation. And these metrics can be really useful for decision makers as well, not just for reporting. So this example presented in Databricks has been a very simplified version of how to measure deforestation, just to fit within the time limits of this webcast. But there are other more complex available geospatial data sets which analysis might also want to consider. So, for example, some data providers can provide real-time deforestation tracking. Also, due diligence statements will need a risk assessment of the country you're sourcing commodities from. So for this example, I'd need an overall deforestation risk statement about Brazil. So there are many potential sources which need to be combined for EUDR reporting. And this again reflects the importance of building a flexible dynamic data platform, like Melissa stated earlier, and to be able to connect and structure these assets. So navigating back to the slides, as a summary of this webcast, we hope you now have an understanding that there's an increasing number of regulations which have increasing complexity. So we spotlighted plastic tax regulations and EUDR, but to address all regulations, we'll really need a combination of leveraging a range of data assets and technologies to support your reporting needs. It's important to build a robust data platform for sustainability reporting as the foundation, but you also might want to build flexibility into this platform to ensure capabilities beyond traditional reporting are enabled. So that means your organization can utilize approaches like geospatial analysis, graph databases, or AI. So here at Thorogood, we have been delivering sustainability initiatives for partners for over 10 years. So from this, we now have developed a Sustainability Accelerator Toolkit, so we can use our data understanding, models, and enterprise-ready templates to support your organization to build a data platform which enables streamlined insights at a global scale. So taking action is really key at the moment. We've helped a number of organizations progress in their sustainability journeys using this approach by identifying their best opportunity, running a workshop, and developing a solution. So if any of this is of interest, please feel free to reach out to us. We're happy to offer a free 1-hour consultation on anything discussed today, or to talk more generally about how to progress with sustainability initiatives involving data and AI within your organization. So thank you very much for joining, and we will now conclude this webcast.